This video is supported by Brilliant.org. Growing up, you were probably taught that there were three primary colors, red, blue, and green. Only that's not completely true. There's actually three other primary colors, one of which doesn't really exist. Let's talk color theory. Actually, bear with me. This is cooler than it sounds. So anybody who's worked at a print shop can tell you that the primary print colors, the primary inks and pigments, are not red, blue, and green. They're actually cyan, magenta, and yellow. And then they add K for black, so CMYK color space. Why a K for black? Because reasons? CMYK is what they call subtractive color, meaning that if you combine them all together, you get black. That's what pigments do. RGB is additive, meaning when you add them all together, you actually get white. This is what light does. And this is the color scheme that's used in video screens. Any device you might have that you're looking at, it's actually made up of pixels. And those pixels are made up of three different components of red, blue, and green light. And by altering the intensities of those different colors, you can create any color on the spectrum. The spectrum of visible light, as you probably know, is just a small sliver of the entire electromagnetic spectrum, which goes from radio waves all the way up to gamma rays. What we can see, everything that we can see, is only in one tiny sliver of wavelengths. Now, if you blow that spectrum up, you wind up with that rainbow pattern that we all are familiar with red down at the end with the longest wavelengths at around 700 nanometers, blue on the other end of the spectrum at around 450. And when those wavelengths enter our eyes, they connect with cells at the back of our retinas called rods and cones. Now, rods only measure the intensity of light. They don't see color at all. The cones, on the other hand, do see colors, and we have three of them, red ones, blue ones, and green ones that are all specifically attuned to those wavelengths. This is known as trichromacy. Now, obviously, we see colors other than red, green, and blue, so when a different wavelength of color enters the eye, say yellow, it activates the red and green cones, and your brain splits the difference, and you see yellow. Same on the other side of the spectrum. Combine green and blue, and you get cyan. Yellow and cyan, you might remember, are the subtractive primary colors. Magenta should be a combination of red and blue, but the halfway point between red and blue on the spectrum is green. But obviously, we don't see green. We see a color that is nowhere on the light spectrum. Our brain just makes it up. So even though magenta is one of the primary pigment colors that you can combine with the other colors to make all the different colors that we experience out there in the world, it doesn't have an actual wavelength associated to it. It is completely made up in our brains. Now, of course, this is how a person with normal vision sees the world, and there are people out there with different types of color blindness. The most common one is known as anomalous trichromacy. So they do have all three of their cones, but they kind of overlap in the wavelengths that they detect. A less common type of color blindness is called dichromacy, which, as you can imagine, means you only have two different types of cones. And then there's monochromacy, meaning you don't have any cones at all. It's just rods, and you see the world only in whites, blacks, and grays. But there are people whose color sensitivity goes in the other direction, because instead of having three cones, they've got four. It's called tetrachromacy, and the people who have it see the world in a different way, with super sight. People with tetrachromacy, also known as tetrachromats, have something in common with cats, or at least a certain breed of cat, and it has nothing to do with their eyesight. And it's not the uncontrollable urge to knock things off of tables. Or it's not only that. Calico cats, you might be familiar with them, are made up of orange and black patches that are made by a combination of one parent that's a black cat and one parent that's an orange cat. Instead of the cat just inheriting the genes for being a black cat or being an orange cat, those black and orange genes kind of battle it out when it's just an embryo, just a few hundred cells. So some cells get the orange genes, some cells get the black genes, and then as those cells divide, they become patches. The thing is, this patching can only occur with competing X chromosomes, meaning that this is only possible when you have two X chromosomes, or a female cat. Therefore, all calicos are female. Cat facts! But you know what you can also get from competing X genes? Tetrachromacy. So all tetrachromats are females. Sorry, guys. Some 12% of women are thought to be tetrachromats, although most of them don't even know that they have it. Those that do know they have it, however, have a bit of a superpower on their hands. A little bit of a superhuman ability. They can't see 10 times as many colors as we can, despite what some clickbait titles might suggest. But they can spot subtle differences in colors that look identical to the rest of us. One study of 23 tetrachromats highlighted a woman named Conchita Antico, who had a fourth cone that could detect certain wavelengths that others couldn't. Conchita was able to distinguish between two orange lights, one of which was a pure orange light and the other was a combination of red and green light. Without her extra cone, those lights would have been indistinguishable. although her training as an artist probably helped as well. The fact that she's an artist shouldn't be surprising. In fact, by the time the study was over, they found 2 more artists that also were tetrachromats. That seems unfair. Like a singer with 2 vocal cords. Being extra sensitive to color does have its downsides, though. There's a journalist named Maureen Seaberg who's a tetrachromat. She talked about how she has a lot of trouble finding clothes that match, because even though the top and the bottom might look perfectly matched to the rest of us, to her, they look wildly different. And Conchetta actually told the people in the study that sometimes she feels really overwhelmed in grocery stores because of all the colors coming off of the signage and the packaging and whatnot. Now, another thing that's interesting is that a lot of tetrachromats have children who are ironically colorblind. It's like they just used up all the cones and now their kids can't get any. In fact, this condition was first discovered in a study of colorblind men's mothers. The author's hypothesis was that if a man has colorblindness because he has abnormal vision coding in his X chromosome, it must be because his mother has at least 4 varieties of cones in her X chromosomes. This is an image from the original paper. It illustrates the cone-coding X genes of one mother, CDA29, and her 3 sons. As you can see, son N29 inherited a normal set of cones, shown here as solid blocks of red and green, while his brothers both got an abnormal red-green mix. Mom has both sets, which caused her eyes to develop a mosaic of normal and abnormal cone cells, similar to how a calico cat develops mosaic fur. So this extra cone, this superpower, obviously it has some advantages in fields like art, but really, humans see color better than most animals do already. Dogs, for example, are dichromatic. They only have 2 types of cells, so they see the world in mostly yellows, blues, and grays, although they do have more light-sensing rods than we do, and they also obviously rely a lot more on smell and other senses. And other animals, especially insects, can see in all kinds of wavelengths that we can't see, but the mantis shrimp is what really takes the cake. It has 16 different types of photoreceptors in its eyes. There's just so much in the electromagnetic spectrum that we just can't see. It kind of seems like a waste, but what if we could see in those wavelengths? Let's start with the infrared, which surprisingly we actually might be able to see more of it than we think we can. A 2014 study concluded that we might actually be able to see at least a little bit of infrared light. They came to this conclusion when participants in their study reported seeing flashes of light when they shined an infrared laser at a certain part of the eye, which, what? Don't shine lasers in your eyes. That does not sound safe. Of course, this could be a similar bright flash effect that astronauts have been reporting for decades, although it's thought that those are caused by cosmic rays. Nobody knows exactly how the astronauts are seeing these flashes. They don't know if it's actually, hitting the back of the eye or affecting the optic nerve, or maybe just penetrating the skull and going right into the vision center of the brain directly. Or the flashes could even be the Cherenkov radiation, which is the light speed equivalent of a sonic boom happening right inside their eyeball. Sonic booms in the eye. Nothing to worry about there. Now, if you really could see infrared light, that would be really interesting. Everything that has heat gives off infrared, so like the human body at 98.6 degrees, it basically just glows, which is why police use it to catch criminals. They've also used it to just scan people's homes to see if they're growing marijuana, because if you have a lot of lights growing the marijuana, that gives off a lot of heat, so from the outside, the house would kind of glow in that one room. Clever, sure, but it was actually declared unconstitutional because it violates Fourth Amendment rights. But the point is, you'd be able to see temperature variations and probably, people inside their homes, stuff you probably shouldn't be able to see. Now, on the other side of the visible spectrum is ultraviolet light, which it turns out you could actually see that as well if you get your lenses removed. The painter Claude Monet had to have a lens removed from one of his eyes due to cataracts, and apparently he saw white flowers as sort of a pale blue from that point forward, and that's reflected in his paintings. Now, if you could actually see UV light, it would be kind of everywhere. UV light is, especially in the daytime, that's why we have to wear sunscreen. That's what penetrates our skin and causes problems there. But at night, the stars would be like super lit up and bright. It would be a fantastic looking scene. You would probably also see ultraviolet light coming out of most light bulbs. But what if you could see the entire electromagnetic spectrum? Now that kind of depends on what you mean by see. Are you actually creating an image, or are you just sort of detecting different wavelengths? Your brain would have a lot of adjusting to do. Presuming it could even do so, it would need to be able to parse out different kinds of the spectrum, because otherwise it would just be completely overwhelming. High energy gamma rays wouldn't be too hard to deal with. The atmosphere kind of filters most of those out from the outside. Probably most of what you would see would come from radioactive sources, which again, hopefully you're not around very much. There's an experiment called the Peltier cloud that allows you to see neutrons firing out of uranium or other radioactive elements. Being able to see gamma radiation might be kind of like this. You'd just see plumes of energy firing out of radioactive sources. Seeing X-rays would be pretty trippy. You know, it travels through clothes and skin, so like as you're talking to somebody, you might see little flashes of their bone structure while you're talking. That might be kind of weird. Luckily, X-rays aren't that common out in the normal world, except for, you know, in doctors' offices. I wonder if you'd be able to see through your eyelids. Radio waves travel in huge wavelengths that can actually go all the way around buildings, so seeing radio waves might be like giant ribbons kind of flowing through cities. But radio actually might be kind of overwhelming because there's a whole lot of it that comes out of the sun, not to mention TV signals, audio, GPS, Wi-Fi. It would just be everywhere. Now microwaves, that might actually be kind of a nightmare because you would be constantly bombarded from light from the Big Bang. Light from the early universe has been stretching throughout all this time, so we actually perceive it now as the cosmic microwave background radiation, which means at night the entire sky would be lit up with microwave radiation. Like it would be as bright as in the daytime, except it would be coming from all directions. Of course, every organism evolves sensitivity to different wavelengths of light that are advantageous to them, you know. The ability to see everything on the spectrum probably wouldn't really be helpful because you wouldn't be able to discern anything. It's thought that we humans developed trichromatic vision because earlier in our days when we were foragers and gatherers, you know, it kind of helped to be able to pick out the different types of fruits and berries and that kind of thing. Of course, in a way, we've kind of evolved beyond our trichromatic vision already. You know, we can manipulate X-rays to see inside the human body. We can make cameras that can detect UV and infrared, and we can use microwave to heat up our Jimmy Dean sausage. So tetrachromats might not have super sight per se, unless you consider not being able to find matched clothing superpower, but it's always interesting when you find out that somebody else can perceive something that you can't. Our conscious experience is just so singular and so subjective. It's just hard to imagine that somebody else can look at the same thing or taste or touch or smell the same thing and get a completely different experience than we have from it. But as we talked about many times on here, our senses are simply the information gatherers that collect information and they send that information to the brain. The brain is what interprets it and gives us the sensations that we feel. So really, when you think about it, it's kind of amazing that we're on the same page as much as we are, all the way down to collectively seeing a color that doesn't exist. But what about you? Do you have tetrachromacy? Are you colorblind? Do you have any other kind of visual weirdness that is worth talking about? Discuss down in the comments. I want to hear about it. And if this whole different wavelengths of light thing has got you curious and you want to learn more about how that works, guess what? There is an entire course called Waves in Light on Brilliant.org. This course helps break down not just visible light waves, but sound waves as well, and helps explain all the ways in which they're similar and different so that you can have a better understanding of both. By understanding how waves work, you'll walk away from this course with a deeper knowledge of earthquakes, noise-canceling headphones, musical instruments, and the Doppler effect. This, of course, is just one of dozens of interactive courses on Brilliant, from basic science fundamentals to advanced calculus that walk you through a series of puzzles so that you can learn it in a way that makes most sense to you, and you can apply that to other areas of your life. You can sign up for free at brilliant.org/answerswithjoe and get access to their free weekly brain teasers and puzzles. And if you want to sign up for the premium subscription that gives you access to all their courses, the first 200 people that sign up for it can get 20% off your subscription for life. Brilliant's been an awesome supporter of this channel, so I am happy to show them some love. Brilliant.org/answerswithjoe. Link is down in the description. Big thanks to Brilliant for sponsoring this video, and a huge shout out to the Answer Files on Patreon that are starting an awesome community and interacting with me. I'm getting to know you guys. It's really awesome. And there's some new people. I gotta murder their names real quick. We got Dylan Hayutin, George Insman, I'm really murdering their names today, Jao Fidalgo, Adsdavs, Bob Kreischer, and Michael Hernandez. Thank you guys so much. If you would like to join them, get early access to videos, join the Discord group, do all kinds of cool stuff, you can go to patreon.com/answerswithjoe. T-shirts available at the store, answerswithjoe.com/shirts. You might notice this is a new one. I got some new ones that I'm going to be wearing, so you'll get to see them. Lots of really fun, nerdy science type shirts. I think you'll like them. Answerswithjoe.com/shirts. Go check them out. Please like and share this video if you liked it, and if this is your first time here, welcome. Thank you for watching, and you might want to watch this video. Google thinks you'll like that one too, or any of the others that I've got down there, and if you like them, I invite you to subscribe. I come back with videos every Monday and every Thursday. All right, that's it for now. You guys go out and have an eye-opening week, and I'll see you on Monday. Love you guys. Take care.